Good day, everyone. This video, I'm going to discuss on Cambridge International AS Physics Paper 1, May June 2024, Paper 1-3. Let us get started. Now, look at the first question. What is equal to 0.0000005 joules? Wow, there's so many zeros there, right? So what am I going to do now is that, okay, if you want to put all the values into your calculator, you just put 0.0000005, then, okay, you get this value. But all you need to do is just to press a button called ENG. ENG. It is between 7 and 8. When you press that, you could see magic occur. So you will get the exact value. So this is in the standard value. So this is 5 times 10 to the power negative 6 joule. Negative 6 is one of the prefixes, which is called micro. C is the answer for the first one. The second question, the measurement of a physical quantity may be subject to random errors and to systematic errors. Which statement is correct, the true one? Let us look at A. A systematic error cannot be reduced by adjusting the apparatus. Actually, a systematic error can be eliminated by adjusting the apparatus, right? So this is wrong. B, a systematic error results in a different reading each time the measurement is taken. Actually, a systematic error will cause the reading to be deviated to one side. Either the reading would be higher than the true reading, or the readings will be lower than a true reading. So B is wrong as well. C, random errors are always caused by the person taking the measurement. Random, the word says it all. Random means it comes from random directions. You don't know what is the exact cause. So that is why it is not always caused by the person taking the temperature. Maybe it is due to the room temperature suddenly change or the room pressure suddenly change. That could be one of the causes of the random error as well. Therefore, C cannot be your answer. Now, D, random errors can be reduced by taking the average of several measurements. This is exactly true. Why? Because random errors are the errors from coming from all direction randomly. You basically do not know what is the main cause of the random errors. That is why to reduce that random error, we take more measurements and then we average, right? That could reduce the random error, which is true. Number three, the Young modulus of the material of a wire is to be found. The Young modulus E is given by the equation shown. E is equal to 4 FL over pi d square x. Wire is extended by a known force and the following measurements are made. Which measurement has the largest effect on the uncertainty of the value of the calculated Young modulus? So if you want to know which has the largest effect or greatest uncertainty. This is Young modulus. Young modulus is calculated by multiplication, by division, by power factor. So how do you find the uncertainty in the Young modulus? You just add its fractional uncertainty. So delta E over E, fractional uncertainty of Young modulus actually depends on 4 is just a number. There is no fractional uncertainty for 4. Delta F, fractional uncertainty of force, plus fractional uncertainty of length. Pi is just a constant. There is no fractional uncertainty, but this is d squared. Hey, this is power factor. So the power you need to times with the fractional uncertainty of diameter plus delta x over x, fractional uncertainty of x extension. Now we are going to find the fractional uncertainty of each and every physical quantities here, right? To check which would contribute to the largest fractional uncertainty. So that will give the largest effect on the uncertainty of the value of Young modulus. So I'm going to do it one by one. So the first one, delta L over L. This is actually delta L. So I'm going to calculate that. Delta L over L is 0.002 over 2.043. I am not going to change that any units because there is no units for fractional uncertainty. So I'm just going to use the number to divide. So this one I got 9.79 times 10 to the power negative 4, right? I just put value first because I don't have to round it off to two significant figures or one significant figure because that's not my final answer. So it doesn't matter how many significant figures that I put there, but I try to put it in terms of one significant figure. So I get this is maybe 1.0, maybe okay, one significant figure, so you just move in front. So this is 1 times 10 to the power of negative 3. Move to the front, right? So what about d? This is d, but this is 2 delta d over d. You have to base on the equation of the Young modulus to do your calculation of the fractional uncertainty. So this is 2 times delta d, 0.02 over 0.54, and you're supposed to get 0.07. And f is delta f over f. This is 0.01 over 19.62. And I got 0.5 times 10 to the power of negative 3. And then, okay, what about this? X is delta x over x, 0.2 over 5.2. And I got 0.04. So if you want to make everything easier for you, this one should be 0.001. This one's supposed to be 0.005. So which gives you the largest fractional uncertainty? The answer is 0.07, which is B. That is why B is your answer. Question number 4. Two physical quantities combined together as a product can produce a scalar quantity or a vector quantity. Now, which product of two quantities produces a scalar quantity? Now, let us look at A. Force multiplies by displacement of the object in the direction of the force. Don't you think this is a definition of work? And work is actually a scalar quantity. A should be the answer, but I'm going to prove that B, C, D are wrong. Mass times acceleration of the mass. This is the force or resultant force. C, pressure times the area on which the pressure acts. This is also force. Velocity times time for which the object, well, velocity times multiplies by the time for which an object has that velocity. Vt, velocity, this is called displacement. Displacement is a vector quantity, force is a vector quantity. Therefore, the answer is A, scalar quantity. Now, question number 5, the diagram shows the velocity time graph for an object moving in a straight line. What is the displacement during the last 2 seconds of the motion? Last 2 seconds is actually this, 2 to 4. This is called last 2 seconds. So they want you to find the displacement. Remember what I told you in my other videos? I said that when a graph is being given, there are two informations that you could obtain from the graph. One is the gradient of the graph. The other one is the area under the graph. Now, the gradient of the velocity time graph gives you, I'm going to write this for you, gradient gives you acceleration. Whereas area under the graph gives you the displacement. So this is the area of trapezium. Half A plus B. 6 plus A is 6. B is 12. 6 plus 12 times 2 seconds. 4 minus 2 is 2 seconds. So you should get 18 meter as the answer. C is the answer. Question number 6. A block is moving along a horizontal frictionless surface. A constant force F and a constant resistive force of 5 Newton act on the block as it is moving in the direction of the force F as shown. The graph shows the variation with time of the momentum of the block. What is the magnitude of the force? Now, when a graph is being given, you are supposed to use the graph to find that F first. Because based on Newton's second law, force is equal to the rate of change of momentum. So it also means that this is the final momentum minus initial momentum per time taken, right? In other words, I'm saying that the gradient of the graph Okay, if you don't use the gradient, it doesn't matter. So you just use the final momentum minus initial momentum divided by the time taken. That will give you the force. F, final momentum is this one because this is at the start of the time. Final momentum is 1.5. Be careful, it is not 0 because you look at your y-axis, this is 1.5. So 1.5 minus initial momentum is when time is equal to 0, which is 2.7, divided by the overall time taken, which is 0.4. So use my calculator. 1.5 minus 2.7 divide 0.4, and you should get negative 3 Newton as the value of F, right? So the magnitude of the force, a constant force is at in the, oh, okay. This is actually the resultant force. Because based on Newton's second law, resultant force is directly proportional to the rate of change of momentum. That is not the value of force. I'm so sorry. It is the resultant force, not the value of force. But based on the diagram, hey, let us look at the diagram again. Resultant force is the sum of all the forces that are acting on one object. So you could see that this is a block. There are two forces acting on the block. One is F, the other one is 5 Newton. And these two forces are acting in the opposite direction. So you have to put positive to one direction and negative to the other direction. I will put positive to F and negative to 5 Newton. Therefore, it is F plus negative 5 Newton, negative 3, because I got the value of resultant force, F minus 5. Therefore, F is equal to negative 3 plus 5. F is equal to 2 Newton. A is the answer. Number 7, Newton's third law describes two forces that are equal in magnitude and form a pair. Which description of the two forces in such a pair is not correct? Right, let us look at the first one. They act in the opposite directions. This is true. B, they act on different objects. Yes, this is true. Newton's third law is about two objects like the sun and the earth, right? The sun exerts the force, gravitational force on the earth, and the earth is also exerting the same magnitude of the gravitational force on the sun. But gravitational force of earth and sun are acting in the opposite direction. And they are the same type of force, yes. Gravitational force of the sun, gravitational force of earth, right? And they causes an object to be in equilibrium. No, there's no equilibrium or resultant in Newton's third law. So D is the answer. Number 8, the graph shows the variation with time of the speed of a raindrop falling vertically through air. Which statement is correct? Now, let us look at A. Acceleration decreases to produce a steady speed. How do you find acceleration from the graph? It is actually the gradient of the graph. But since this is a curved graph, you have to draw tangent. So you look at my tangent is getting less steep and eventually it is equal to 0. At this point, acceleration is equal to 0 because my tangent forms a horizontal line. Horizontal line will give you 0 gradient. That is also means that the object or the raindrop will travel at terminal velocity when A is equal to 0. First statement is actually correct, but I'm going to look at B, C, and D first. B, the acceleration increases. No, the acceleration is decreasing because the steepness of your tangent line is decreasing. C, the air resistance decreases as the speed. No, air resistance will follow the speed. When the speed is increasing, the air resistance must increase as well. This was supposed to be increased. B is supposed to be decreases. D, the resultant force increases. The resultant force is actually based on acceleration because the acceleration depends on the resultant force. Resultant force is actually decreasing due to the fact that acceleration is also decreasing, right? Therefore, the answer is A. Question number 9, which statement about a perfectly elastic collision between two objects is correct? A, the total kinetic energy is conserved, which is true because total initial kinetic energy must be equal to total final kinetic energy. That's true. And the relative speed of approaching equals to the relative speed of separation. This is definitely 100% true. A is the answer. What about B? Total kinetic energy is conserved, but the relative speed of approaching is not equal to the relative speed of separation. This is wrong. See, total kinetic energy, no, this is only for when the total kinetic energy is not conserved, that is related to inelastic collision. Therefore, the answer is A. Question number 10. The diagram shows the view from above of a sprinkler system used to water a garden. The sprinkler consists of a tube of length 0.15 meter. Tube is pivoted in the middle and spins in a horizontal plane as it lets out jets of water from each end. The two water jets are in opposite directions to each other. Each water jet exerts a horizontal force of 3 Newton on the tube at right angle to the tube. So this is 3 Newton. What is the magnitude of the torque on the tube from the water jets? Water jets. This is actually torque of a couple. These two forces are actually coupled. Why do I say so? Because first of all, their magnitudes are the same. Second, they're acting in opposite direction. Third, they are being separated by a distance, which is 0.15. So I'm going to find the torque by the two jets. So you can use torque of a couple. You just take the magnitude of one of the two forces, multiplies by the perpendicular distance between the two forces, which is 0.15 meter. You're supposed to get 0.45 Newton meter. C is the answer. Continue with question number 11. An object is held equilibrium by three forces. The forces all act in the same plane. The diagram shows two of the forces that act on the object. The third force is missing from the diagram. What is the third force? First of all, I am definitely going to draw my triangle, right? So as long as I draw a vector triangle and the directions of the triangle could form a close triangle, these three forces are in equilibrium. First of all, I draw the, oh, okay, I better use a ruler to draw it. So I'm going to take out my ruler. Straight force first, 43 Newton. I'm going to draw it right here. Okay, maybe here. So this is my 43 Newton. And then it follows by, okay, the tip of the 43 Newton is being, okay, okay, I make sure that this force is like that, is joined by the tail of 17 Newton. So I just draw my I just draw my 17 Newton here. And then, okay, my resultant force would be, not resultant force, I'm sorry, there's no resultant force because the system is in equilibrium. So I'm going to draw my third force to form equilibrium. I'm going to draw the arrow later. So this is my third force. Now I keep my ruler first. Okay, so it has to perfectly form a circle. This is right, perfectly form a close triangle, not a circle, right? So I have the angle here. How do I get this angle between 17 and 43? I'm actually using the parallelogram rule. This angle is calculated from 180 degrees minus 125 degrees. That gives you 180 minus 125. That gives you 55 degrees here. So this is 43 Newton. This is 17 Newton. If I want to find the third force, which is the red line there, the magnitude of the third force, I need to use the cosine rule, right? A square is, C square is equal to A square plus B square minus 2BC cos C, right? So now I'm going to use, I will put this as the third force F. F is equal to, F square is equal to 17 square plus 43 square minus 2 times 17 times 43 cos 55. From there, I got 17 square plus 43 square. Here I got, okay, minus 2 times 17 times 43 multiplies by cos 55. And I got 1299. F squared is equal to 1299.43. Therefore, F is equal to square root the answer, and I got 36. So 36 Newton is the answer. The answer is quite obvious, which is B, but I'm going to prove that angle is 157 degrees. How do I do that? First, it is not easy, seriously. I'm finding this angle first. I used to find this angle, theta, is because I don't know whether the value of f is correct. That is why I want to use the sine rule. A over sine A is equal to B over sine B. So I am going to use 17 over sine theta is equal to is equal to 36 over sine 55. Sine 55. So you do your cross multiplication. 17 sine 55 is equal to 36 sine theta. Therefore, theta is equal to 17 sine 55 divided by 36. And then you shift the sign, invert the sign. So your theta supposed to be, let me do it. 17 sine 55 divided by 36, and then shift sign. You're supposed to get 22.75. So this is 22.75 degrees. Right, so when this is 22.75 degrees, this is a this is a triangle. So this is 180. You just minus 55. You will get 102.2 degrees here. Right, and then it is not that angle because it is the angle based on vertical. So it is a vertical line here. So the angle of vertical here is 55 degrees. So how do I know that is 55 degrees? Okay, because based on this angle, this was supposed to be 125, right? So this is 55 plus 102.2. You get 157. B is the answer. Now, question number 12. The total number of forces acting on an object is 2. The object is in equilibrium. Which statement about the forces are correct? Now, first one, the two forces must have equal magnitudes. Yes, because when the object is in equilibrium, that also means that the resultant force acting on the object must be equal to 0. Now, second one, number 2, the two forces must act in the same direction. No, doesn't mean that two forces must act in the same direction in order to achieve equilibrium because, right, the second condition for the equilibrium is that the total moment must be equal to 0. That means anti-clockwise moment must be equal to clockwise moment. This is not always correct. Third, the two forces must act through the same point. Yes, it is true because when they add on the same point, right, the total resultant force is equal to 0, or resultant force acting on an object is equal to 0. Resultant moment is also equal to 0. So 1 and 3. B is the answer. Number 13, the diagram shows the arrangement of atoms in a particular crystal. Each atom is at a corner of a tube. Mass of each atom is 3.5 times 10 to the power negative 25 kilogram. Density of the crystal is 9.2 times 10 to the power 3 kilogram per meter cube. What is the shortest distance between the centers of two adjacent atoms? Now, first of all, mass and densities are given. Therefore, I'm going to use that to find the volume of the crystal first. Density is equal to mass over volume. Therefore, volume is equal to mass divided by density. Mass is given as 3.5 times 10 to the power negative 2 times 10 to the 8 times. Right. So this is the volume. Another hint is that this is the volume of a cube. Remember, volume of the cube is equal to L cube. What is L? The distance, okay? The length. This is L, this is L, this is L, L cube. So if you want to find the shortest distance between the two adjacent atoms, you just need to find L. right? So put this 3.8 times 10 to the power negative 29 is equal to L cubed. Now L is equal to cube root 3.8 times 10 to the power negative 29, and your answer should be 3.36 times 10 to the power negative 10 meter, which you round it off to 3.4 times 10 to the power negative 10 meters. C is the answer. Number 14, four measuring cylinders are filled with the same liquid to the heights shown. At which position is the pressure the greatest? Now, this is a liquid. At the surface of the liquid, the depth is measured. Pressure of the liquid, let me give you first, rho GH. The H must be measured from the surface of the liquid. So when the H from the surface of the liquid is getting further away from the surface of the liquid, pressure is higher. Right. Now look at A. A, the length, okay, or the depth of the liquid in the measuring cylinder is 30 cm. But right, okay, the position is at A, at the surface of the liquid. So definitely the pressure is not the highest because it is at the surface. What about B? B, this is 30. So B, the depth is 20, sorry. This is 30 and this is 10. So from the surface of the liquid, the depth of B is 20 cm. C is at the surface of the liquid, so this is not true. D is only 10 cm. The H is only 10 cm measured from the surface. Now, which one has the greatest height or greatest depth? It is actually B. Therefore, B is the answer. Number 15, in many filament lamps, as much as 92 joules of energy is emitted as thermal energy for every 8 joules of energy emitted as light. What is the efficiency of a filament lamp as the percentage of electrical energy converted to light energy? Now, efficiency, remember this is the equation of efficiency. Efficiency is equal to useful output energy, I put it at E, over input E times 100%. Now, I have useful output energy because output energy is emitted as light energy. So 8, but I don't have the input energy. Input energy is equal to useful energy plus wasted energy. Wasted energy is 92 joules. Input energy is 8. Useful energy is 8 joules. Wasted energy is 92 joules. So the input energy is actually equal to 100 joules. So 100 joules times 100%. So you get 8%. A is the answer. Number 16, what is the unit of power? Let us look at the definition of power then. Power is defined as work done or energy per time taken. Energy must be measured in joules and time is measured in second. Joule per second. D is the answer. Number 17, an object is in a uniform gravitational field. The graph shows how the change in gravitational potential energy, delta EP, of the object varies with the vertical distance x moved by the object from a fixed point. Now, at which graph shows how the gravitational force acting on the object varies with distance x? I could say that the change in gravitational potential energy is equal to mg delta H. This delta H represents X. So that is why when the delta H is increasing, the gravitational potential energy is also increasing. But since they asked us about gravitational force, I could modify this to weight. This is called gravitational force, or it is equal to force. What happened to the force, gravitational force? Gravitational force will be constant because gravitational potential energy changes due to the changes in height, not the force. So the force is always constant, no matter what is the distance of the x. Because after all, the object is still in a uniform gravitational field. Uniform gravitational field, uniform gravitational force acting on the object with the uniform gravitational acceleration. C is the answer. Question number 18. A block of mass 2 kilogram is released from rest, u equal to 0. I love to put that. It travels 7 meter down the slope and falls a vertical distance of 3 meter. The block experiences a frictional force parallel to the slope of 5 Newton. What is the speed of the block after falling this distance? Hey, do you know what? I'm going to use the principle of conservation of energy. How about that? So initial energy, total initial energy must be equal to total final energy. See, then another hint given by the question is that this block experiences frictional force, right? Therefore, your initial energy is initially the block is at a certain height, so it has GPE, gravitational potential energy. But when it moves down, it experiences frictional force. So you have to do work against this frictional force. Then only equal to your final energy, which is kinetic energy of the block. GPE is equal to mgh. Work done against the frictional force is the frictional force times the distance moved, equal to half mv squared. That is the kinetic energy. Mass of the block is given as 2 kilogram. G is 9.81. H is 3 meter. Minus frictional force 5. And the distance at by this frictional force is 7 meter is equal to half 2nv squared. Now I'm going to continue here. If you work it out, you should get your V as 4.88 meter per second, which you round it off to 4.9 meter per second. A is the answer. Question number 19. Two wires, one made of brass and the other of steel, are stretched in an experiment. Both wires obey Hooke's law during this experiment. The Young modulus for brass, I better write it down. Young modulus for brass is lesser than the Young modulus of steel. Which graph shows how the stress varies with strain for both wires in this experiment? How do we determine Young modulus? It is actually from stress strain graph, right? It is the gradient of the stress strain graph because Young modulus is defined as stress divided by strain, right? So since the Young modulus of brass is lesser, that is why I would expect the gradient of brass is lesser as compared to the gradient of steel. B is the answer. Because I cannot choose A, I cannot choose C. Why? Because these two wires obey Hooke's law. Hooke's law, it is a straight line graph from origin. Question number 20, a sample of material is stretched by a tensile force to a point beyond its elastic limit. Tensile force is then reduced to 0. Force extension graph is shown. When a material is being stretched beyond the elastic limit, I am very sorry, plastic deformation will occur and the material would never ever go back to the original size, original dimension. Which area represent the net work done on the sample? Okay, when the object is being stressed, work, right? Okay, initial work. Okay, it has to be work done on a sample. Then, remember, when you let go of your force, the object, this material is trying to restore back, but too bad. When it is being stretched beyond elastic limit, there is no turning back to the same size, same dimension anymore. So minus the work done by material. Work done on the sample is X plus Y plus Z. The whole thing here. Work trying to restore back is this one. Can you look at the arrow? This is the arrow that the material tries to restore back. But too bad, stretch beyond elastic limit, there is a permanent extension here. So minus C. That is why net work is X plus Y, which is B. Question number 21, a wire is fixed at one end and is extended by a force F1 acting on the other end. This causes the wire to have an elastic potential energy of 0.15 joules. The force applied to the wire is now changed to a force F2. This causes the wire to have a new elastic potential energy of 0.6 joules. The wire obeys Hooke's law. What is the relationship between F1 and F2? Now I have to do it one by one. So elastic potential energy, I use E is equal to EPE is equal to half F1x for the first one. And then I have 0.15 is equal to half F1x. And then for the second one, I have 0.6. EPE 0.6 is equal to half F2x. Right, I would have a different X because due to the different elastic potential energy and different forces, because the question did not say that these two wires, this wire is being extended to the same extension. They would just give us the force and then causes a new elastic potential energy. So I will have to use X2. But from Hooke's law, F equals Kx. Now, because I want to relate F and the two F's, that is why I'm going to replace my X. X is equal to F over K. A wire, right, will have the same K because it is the same wire, right? So for the first one, I have 0.15 is equal to half F1. X1 would be F1 over K. K will be the same. Now, wire, the second condition is that, okay, the second force when it is applied, so this is half F2, X2 would be F2 over K. Simplify this, I have 0.15 is equal to F1 square over 2K. And then the next one, I have F2 square over 2K. Now I want to relate F1 and F2. That is why I replace the K first. From here, I have 0.15. I have 0.3K is equal to F1 square. K is equal to F1 square over 0.3 into equation 1. Now I have 0.6 is equal to F2 square over 2 first. 1 over K, that is 0.3 because 1 over K. So I would just invert this over F1 square. So I have here, I'm going to continue down here. I have 0.6 times 2 divided by 0.3. So I have 4 equals to F2 square over F1 square. 4F1 square is equal to F2 square. Now, square everything. 2F1 is equal to F2. The answer is quite obvious, which is C. So this is the answer. Question number 22, the diagram shows a representation of a wave on a screen of an oscilloscope. The Y gain is set to 3.5 millivolt per cm. What is the amplitude of the wave? If you want to find the amplitude of the wave, you have to look at the Y gain. Now, amplitude is defined as maximum displacement from equilibrium position. Don't you think that this wave is lack of equilibrium position? Right? Equilibrium position will be here. Equilibrium position is a horizontal line that split the two peaks of wave into equal height. This is my equilibrium position, or sometimes it can be called fixed position or fixed point, right? I look at the height of the peak, one of the peaks here, which is 2 cm. Now, amplitude is equal to 2 cm, the height, times 3.5 millivolt per cm. cm cancel, therefore you get 7.0 millivolt as the answer. C is the answer. Question 23. A transverse progressive wave on a string has a wavelength of 12 cm and an amplitude of 1.5 cm. The speed of the wave on the spring, the speed of the wave on a string is 48 cm per second. What is the distance traveled by a point on the string in a time of 2 seconds, right? Now, first of all, I find the frequency first. V equals F lambda. F is equal to V over lambda. I am not going to change the cm to meter because my speed is measured in cm per second and my wavelength is also cm. That is why I'm using 48 divided by 12 and I got 4 hertz. From there, I'm going to find period. Period is 1 over frequency, so 1 over 4, which is equal to 0.25 second because they give me the time. Right, So for a wave, I would like to draw my wave here. Okay, this is a wave profile of my wave. Now, they said that, oh, where's my wave? Okay, so this is a wave profile of my wave. Now, the question said that, keep on disappearing. I also don't know why. I will redraw it maybe here, somewhere here. Okay. Okay, keep on disappearing again. Maybe I should draw here. You're not disappearing here. Not disappearing here. Okay, not disappearing. Okay. Now, I want you to look at the wave. When this is about transverse wave, beware. Particle will oscillate up, down, up, down, right? For a complete oscillation, time taken for a complete oscillation is that particle must oscillate up, down, right? The amplitude is 1.5. This is 1.5 cm. This is displacement measured in cm, right? So the time taken for 4 times 1.5, 1, 2, 3, 4. 4 times 1.5 is equal to 0.25 seconds. That is one period. Now, 2 seconds, I do cross multiplication. So I take 4 times 1.5 times 2 divided by 0.25. And that is the distance traveled by the point, because the point can only travel up and down between the fixed position. 4 times 1.5 times 2 divided by 0.25, and I got 48 cm. C is the answer. Question number 24. An ambulance siren emits a sound with a single frequency F. The ambulance travels towards, passes close to, and then travels away from a stationary observer. Which statement describes the frequency of the sound detected by the observer as the ambulance passes the observer? Now, describe the frequency of the sound detected by the observer as the ambulance passes, right? Ambulance come towards. Before passing, this observer will hear the frequency, which is equal to the frequency, exact frequency emitted by the siren first. And then when the ambulance passes the observer, the frequency will be decreasing. This is Doppler effect. A is the answer. Now, question number 25. An electromagnetic wave has a wavelength of 138 picometer in a vacuum. To which region of the electromagnetic spectrum does this wave belong? Actually, I didn't memorize the wavelength. I memorized the frequency. Now, I have to do it in terms of frequency in vacuum, meaning to say that the electromagnetic waves travel with the speed of light. V equal to F lambda is the equation that I'm going to use. Speed of light, 3 times 10 to the power 8. I need to find the frequency of this electromagnetic wave first. 138 pico is 10 to the power negative 12. Frequency is 3 times 10 to the power 8 divided by 138 times 10 to the power negative 12. And I got 2.17 times 10 to the power 18 hertz. 18 hertz is in terms of in the region of X-ray. Yeah, it is very high frequency. Question number 26. A student investigates the polarization of a microwave. The microwaves from the transmitter are vertically polarized. A metal grill acts as a polarizing filter when placed between the microwave transmitter and the receiver. Reading on the voltmeter is proportional. Voltmeter reading is proportional to intensity of the microwaves transmitted through the grill. When the transmission axis of the grill is vertical, the voltmeter reads 3.5 volt. The grill is then rotated through an angle theta. Voltmeter now reads 2.2 volt. What is theta? I am going to use this equation. I is equal to I naught cos square theta. Since the voltmeter reading is proportional to the intensity, I am definitely going to replace this with V equal to V naught cos square cos square theta. Now the initial reading is 3.5 and then rotated, the reading is 2.2 cos square theta. Now 2.2 divided 3.5 is equal to cos square theta. Now 0.6286 is equal to cos square theta. Just square root shift cos first, yeah? And then just use square root theta, supposed to be 37.5 degrees. A is the answer. 27. Two waves superpose. A resultant wave pattern is formed. Which statement about the two waves must be correct? They have the same amplitude. No, it isn't necessary to have the same amplitude, right? They are of the same type. Yes, my sound wave must interfere, superpose with another sound wave because my sound wave can superpose with a light wave. Don't you think so? That is true. They are transverse wave. No, longitudinal wave can superpose as well. They travel in the opposite direction. Must be correct. No, they could travel in the same direction. Right? As long as one is faster or one is slower compared to the other one. B is the answer. 28. A water wave passes through a gap in a harbor wall and diffracts. The gap, it has a width of 8 meters. The wave travels directly towards the gap. For which wavelength is the diffraction of the wave greatest? Now, this one you don't have to do any calculation. In order to view for the greatest diffraction, the size of the wavelength must be equal to the gap, the width of the gap, which is 8 meters. D is the answer. Number 29, light of wavelength 5.5 times 10 to the power times 10 to the power negative 7 meter from a laser is incident normally on a diffraction grating. The diffracted light is incident on a semicircular screen as shown in the view from above. Now, a total of 9 bright dots are formed on the screen. The grating is at the center of the semicircle. The lines on the grating are vertical. The separation between the adjacent lines in the grating is D. What is the possible value of D? Now, I'm going to do this because they told us that total number of diffracted dot is 9 dot. So total dots is equal to n multiplies by 2 plus 1. Why do I multiply by 2? N is the number of dots, right? So the total dots that I get is here. I want to see n. N is the number of order. So it is actually the number of order multiplied by 2. Is just because there are 2 first order, 2 second order, 2 third order, etc. And plus with the 1. 1 is the undeviated beam, right? So n times 2 plus 1, work out for n. N is equal to 9 minus 1 divided by 2, so you get 4. Now, use the diffraction grating equation. D sine theta is equal to 4 n lambda. Sorry, I'll just put here n lambda. D sine theta must be sine 90, and because total number of dots given is when the angle is 90 degrees. This is 4. Lambda is 5.5 times 10 to the power negative 7. Sine theta is 1. That is why D is equal to 2.25 times 10 to the power negative 6 meter. A is the answer. 30, which quantity is given by the product of charge and electrical potential? That is called energy because E is equal to VIT. IT, kilowatt. So that is why B is the answer. 31, the current in the filament lamp is increased. When the current in the filament lamp is increased, right, resistance of the filament lamp must also increase. Which statement about the lamp is correct? The brightness of the lamp would decrease. Not always true. The potential difference across the filament lamp is decreasing. No, not true. The resistance of the filament is decreasing. No, not true. And the temperature of the filament lamp increases. This is most of the problem that we are facing with filament lamp because the temperature of the filament lamp easily increasing. That is why the resistance will have to increase due to the amount of the current that flows through it is increasing. That is why, right? It is the temperature of it will increase. And the brightness of the lamp cannot decrease because the brightness of the lamp depends on the current. Now, 32. A student builds the circuit shown. All the lamps are identical. Which lamp dissipates the most power? The lamps that dissipate the most power, I'm using P equal to I square R. The largest I will give largest power because all the lamps are identical, so they share the same resistances. D is the answer because the current has yet to split or the current combined together before going back to the negative terminal. 33. The resistance of the metal cube is measured by placing it between two parallel plates as shown. The cube has a volume V and is made of material with resistivity ρ. The connections to the tube have negligible resistance, which expression gives the electrical resistance of the metal cube between X and Y. Now I'm going to use resistance is rho L over A. The problem is they give us a volume. No worries. Volume is equal to area times the length. I'm going to replace that. R is equal to rho L. Volume, okay, area is equal to volume over length. So that is why this is per volume, length square. So I am going to use this expression. Now, R is equal to, length is not given. Okay, never mind. No problem with that at all. Do you know why? Because there's another hint. This is a cube. Volume of the cube is length cube, right? So this is length square. That is why it is volume 2 over 3. Right, because volume is equal to length cube. So that is why length is equal to V1 over 3. But this is length square. So that is why length, okay, so I'm just going to do it a bit here. R is equal to rho L square. So V1 over 3 times 1 over 3 times 2. So that is why you have V2 over 3 over V. Now, simplify. V2 over 3. V here is 1. You move out minus 1. So you have rho V negative 1 over 3. Or rho over V 1 over 3 is the answer. C is the answer. Question number 34. A circuit needs to be completed by connecting two resistors between points X and Y, as shown. The resistors can be connected in series or in parallel with each other. Which combination of the resistor produces the least resistance between X and Y? To produce the least, you don't choose series, you choose parallel. Right? So we compare between these two, right? Total resistance 1 over 20 plus 1 over 40. Inverted, you should get 13.3 ohm. For this one, total resistance is equal to 1 over 40 plus 1 over 100. Inverted, you should get 28.57 ohm. So A is the answer because I want the least resistance. Question 35. The diagram shows a circuit that includes a cell with internal resistance. The switch is initially open. Which row describes the effect on currents I1 and I2? Closing the switch, right? Closing the switch, current from I1. This is when the switch is open. Okay, only this resistor. When the switch is closed, these are the two resistors, right? Connected in parallel. So when the switch is closed, R total resistance decreases. That is why I1 will have to increase. So it's either C or D. Now using the EMF equation, V plus IR. V means terminal potential difference. EMF is constant. Bear this in mind because they did not mention that they changed the cell, right? But since I1 increases, I1 is the one that passed through the internal resistance. I1 increases, which makes the potential difference across the internal resistance to increase. That is why the potential, the terminal PD would have to decrease. Terminal PD, you can use Ohm's law, I2 times R total. So I2 would have to decrease. C is the answer. 36. The diagram shows a circuit consisting of a cell and three resistors, R1, R2, and R3. The cell has EMF, electromotive force, EMF, 1.6 volt. I better write it down. And negligible internal resistance. The current in the cell is 0.64 ampere. The potential difference across R1 is 0.48. The current in R3 is 0.32 ampere. Now, what is the resistance of R2? Right, there you can use Ohm's law to do it. Resistance of R2 is equal to V across R2 is equal to I times across R2 times the resistance of R2. Don't you think so? Now I have to find the potential difference across R2 because R2 and R1 are being connected in series. So the potential difference across R2 is 1.6 volt minus 0.48 volt, which gives me 1.6 minus 0.48, it gives me 1.12 volt, 1.12 volt. And what about the current across R1 and R2? Now use Kirchhoff's first law. Total current in is equal to total current out. Current in is 0.64. Current out is equal to 0.32 plus I just put I here, right? So I is equal to 0.64 minus 0.32, right? So 0.64 minus 0.32 and I got 0.32 ampere as the value of the current. Now I have all the information that I need to find my R2 value. 32 R2. R2 is equal to 1.12 divided by 0.32 and you're supposed to get 3.5 ohm. C is the answer. Question 37, the diagram shows a potentiometer circuit used to compare the electromotive forces EMF, E1 and E2 of two cells. XY is a uniform resistant wire. The fixed resistor has resistance R. The sliding contact is moved along the wire XY. When the sliding contact is at position P, the galvanometer reads 0. The circuit is changed so that the galvanometer reads 0 when the sliding contact is at a new position to the left of P, maybe somewhere here. Which change could have been made to the circuit? Now, I am using potential divider concept. V output over V input is equal to R output or length in this case. V out over V in is equal to length out over length in. This is a general equation of the potential divider that I will be using here. So I put E2 over E1 is equal to length out over length xy. Length xy would never change. Now they say that the galvanometer is not reading 0. And oh yeah, to the left of P. So to the left of P, maybe it could be increasing, it could be decreasing, it depends. So I have to look at R output over R input. Right to the left of P, the length of the wire here is actually decreasing. The length output is decreasing. So that also means that my E2 reading would have to decrease. Right, okay. Now I don't have E2, which is decreasing. The wire is not being replaced because they didn't mention that. E2 lower resistance is not possible. E2 was increased, cannot be because E2 must decrease because the output length is decreasing. E1 was decreased. No, there's no change to E1. It doesn't affect the E1. So the R, okay, now let us extend to that. When the length output decreases, the R output will also decrease. This is true. D is the answer. Question 38. Nucleus P has 144 neutrons and 93 protons. Nucleus P is unstable and undergoes alpha decay to form nucleus Q. Nucleus Q then undergoes beta negative decay to form nucleus R. Nucleus P is represented by point P on the graph. Which point on the graph represents nucleus R? So nucleus P is here, 93 proton, right? And then nucleon, okay, 93 is here. To find the nucleon number, you have to take neutron numbers, 144 plus 93 plus proton number. This is 237. And then undergo beta alpha decay for 2He and undergo beta negative to form R. Right? Now I have R is equal to 237 minus 4, which is equal to 233. 93 minus 2 plus 1, which is equal to 92. So R must be somewhere 92, and then the neutron number, neutron is equal to 233 minus 92. 233 minus 92, which is equal to 141. So A is the answer. 141 number of neutrons and 92 proton numbers. A is the answer. Number 39, the diagrams show the quark composition of 4 different hadrons. One of the hadrons is a sigma plus particle. It has a charge of positive E, where E is an elementary charge. Which hadron could be E sigma plus particle? Sigma plus particle with positive, so it has to be 2 up quarks and 1 strange, because up quark is plus 2 over 3e. So you have plus 2 over 3e plus 2 over 3e minus strange is negative 1 over 3e minus 1 over 3e. So you get 4 minus 1. So this is 3 over 3e, which is positive e. Right? What about C? C is 1 up quark, 2 over 3 minus 1 over 3 minus 1 over 3. 2, this is 0. C is neutral. What about B? B is negative 1 over 3e, strange negative 1 over 3e, and strange negative 1 over 3e. You get negative E for B. And A, negative 1 over 3e, negative 1 over 3e, and negative 1 over 3e. You get negative E. That is why D is the answer. Question 40, which type of particle is comprised of the most quarks? Baryon is the answer, because baryon consists of 3 quarks. So that's the end of our discussion of May June 2024 paper 1-3. I hope you gain benefit from that. So if you have any hesitation, any question, or you need the full PDF solution for free, please do comment below. Bye. See you in my next video. Bye. Take care.